Hi everyone, welcome back to my YouTube channel. In this video, we will learn about strategy design pattern. We will start with an example and then later we will see what downsides it has and how we can update the code so that we follow the best design pattern to solve that problem. Then we will come to the strategy design pattern definition. So the given example is payment processor. So whether you are running your e-commerce business or you are having any other business, you have to process customers payment. So let's say you have a method process which has two parameters, type and amount. So based upon the type of payment you have to process, like credit card or UPI, there is a logic of processing that payment. So it might be like calling the credit card API to complete the payment, and here calling the UPI API to complete the payment. So now let's say you have another case of debit card. So let's say debit card in future you want to accept through, let's say, blockchain or like Bitcoin. So this class will keep adding new type of payments it has to process, and also it will keep adding the logic. So even though let's say right now we have the three payments, but let's say the API changes, still we have to go to this class and update that logic if the logic of the credit card payment processing is changed. So it has the problems. One is violation of open close principle, since if even if the logic of credit card changes or it has a new type, in both the cases it violates open close principle. Also, payment processor manages logic for all the payment types, causing bloating of too much logic into a single class. This is getting long and long as we have the new payment method. So now let's see how we can update. So we discussed like there are two problems in the open close principle. One is the logic will keep getting changed with time. Second is addition of the new payment types. So let's solve this first problem, in which let's say the code of credit card changes. Still we don't have to change this class. So what we can do is we can simply, we have named it strategy, just ignore it right now, just consider that as another class. So how we can update this code is like just place this logic into a new card, a new class. So let's say that new class is credit card payment strategy, UPI payment strategy, and debit card payment strategy. So now all this logic will be encapsulated into these classes. So let's say all of them have a pay method, and it just accepts the amount because the type is now determined in this strategy. So we just need the amount to get the payment processed. So it solves the first problem, that we don't have to update the code if the credit card or UPI or debit card logic changes. But it still have a problem that even if we have to add a new type of payment to process, we will have to update this class. So let's see how we can solve this problem. So this is what we already have discussed. So now what we can do is, like, instead of determining the type of payment, we just delegate it to our client or like whosoever is calling to inject a payment strategy. So instead of payment processor having to decide which type of strategy or which type of payment strategy to use, we just delegated it to client. So what, whenever client creates the payment processor, its responsibility is to provide a class which will have the logic to accept a payment. So now if we have to process, we just have to call strategy.pay. So instead of determining the strategy inside the class, we delegated it and determined it outside the class while building the payment processor. So this simplified our code also. So now whenever there is a logic change of addition of any new payment type, this class doesn't require a change. Its parent or the class which is building its uh, object, that will inject a different strategy. So based upon that, this logic will all remain the same. So how this is feasible, it is because the payment strategy is an, let's say, interface, and all of these has should extend this strategy so that any one of them can be injected in the payment processor. So this exact simplification is the strategy design pattern. Like the client decides the strategy, injects that, and then that strategy has the algorithm or logic to run your code. So now this class is completely closed, but it's open for extension. So now let's say you have added a payment strategy. Later you want to change it. You just set it with the new payment strategy. You don't have to change the code, but you have changed the way how it behaves. So this is the behavioral design pattern. So we will look at the classes. So payment strategy is the interface which has the pay and amount. All of them extends. It has to extend so that we can put any type of payment strategy here. So every class itself will have the logic of how to process that payment, how client will use it. So this is like client using it and changing the behavior. So it has a payment processor, so it can be passed in the constructor as well, or like the strategy can be set explicitly using the setter. That depends upon the more low level implementation. So let's say we want to accept the payment through credit card, so we have set that to credit card strategy, and now we just have to call that process. So similarly, when we want to change the behavior, now we want debit card payment to be accepted, we just updated the strategy and just processed it. So this is changing the behavior on runtime, behavioral design pattern, and different strategies you can use. Different strategy is simply an algorithm. You can change the algorithm at runtime. So this is simply strategy design pattern. Now let's look at the class diagram. It's what we have observed in the all previous slides. We have the payment processor, and payment processor contains a payment strategy. It's a private data member. Then it has the set strategy. Set strategy is required to change the behavior in runtime, and it has process payment, which will process the payment. And then the payment strategy is an interface. It payment processor just contains the interface, and its implementation is injected into it. So this credit card, it also implements pay. This debit card, it also implements pay. This UPay strategy also implements pay. So this is a strategy design pattern. Let's go through the official definition as well. Strategy design pattern is a behavioral pattern that encapsulates a family of interchangeable algorithms. So what we did is we interchanged the algorithms. So these are called family because they serve the same purpose, like processing the payment, into separate classes. Like we have encapsulated them into separate classes and allowing a client to choose and switch between them at runtime. So this is the client code. Client code is that code who is executing the code which you are providing. So client code can switch and change between the strategies, between the behaviors at runtime without modifying the core code. So this is all about strategy design pattern. Hope you have understood that. So thank you very much. Stay tuned for the next videos. Thank you.